Okay, this is a user submitted limit that someone emailed me and asked me to make a video of it, and I've been making videos for my own students for AP Calculus class, but I generally just make them private. But I just decided to do this one because it's a good limit, and I figured I'd show you a couple of ways. So first thing that we want to notice here, well, we want to read the problem. It's the limit as x approaches or goes to, however you want to say it, as x arrow -4, as x goes to -4. Now there's no superscript of a plus or a minus, so we know we're coming in from both sides. It's a double-sided limit of the ratio x squared minus x divided by, x squared minus x minus 20 divided by the quantity x plus 4. So the first thing we want to do with any limit is we want to look at the form, which basically what it looks like when we just plug in this number right here, -4. So I'm going to plug in that number. So -4 squared minus -4 minus 20 divided by -4 plus 4. So in the numerator we get a 16 plus 4 minus 20 over 0. 16 plus 4 is 20, 20 minus 20 is 0. So we know the top is 0 over 0. So we know this is an indeterminate form. This is 0 over 0. Now we could use L'Hopital's rule, and I'll do that in a second, but if you haven't approached that point in your calculus course, some people don't even do it in the first level calculus course. If you haven't done derivatives, you have to do derivatives where you can do L'Hopital's rule. You have to do it, well, I guess what we call the long way, which I kind of think is more elegant, to be honest with you, and more convincing to me. So basically what you do is, I'm just going to take the expression x squared minus x minus 20 over x plus 4, and I'm going to see if I can alter it in any way in order to get, when I test the form again, when I plug in this -4, do I get something besides 0 over 0 that's not indeterminate? And if I do, then that's the limit. And we can say that if I don't, then depending on what it is, I do something else. If I get another indeterminate form, I do something else. And if I don't, then like if I get an infinity, well, if that's an acceptable limit, then I say infinity. Anyway, so in general, if you have a rational function, which this is, or a rational expression, this is a function though, since we're taking a limit. This rational expression, x, because it's a polynomial divided by a polynomial, in general, I mean, you're going to try to factor if possible. So I'm going to factor the numerator. The numerator factors into x, what is it? 2 factors of -20 that add up to -1 would be -5 and +4, right? -5 times +4 is -20. -5 minus +4 is -1. So that gives us, and the clue here is too, because this is a textbook problem and generally you're engineered for you to understand them and get results like this, we already kind of knew that we were going to get a factor of x plus 4, so we could kind of cheat there and kind of figure it out from there. But anyway, this is calculus and not algebra, so won't dwell on that. So of course, if we remember, we have the common expression, so we're left with x minus 5. So now we'll look at the form. After we've factored, we'll put in, see if we get a number. We're not going to get 0 over 0. So we put in -4 minus 5 equals -9. We got a number, so therefore we have a theorem that says if we have a function who's equal to our function that we're taking a limit of on every point except the point possibly that we're taking our limit to, which in this case we are, this function right here, x squared minus x minus 20 over x plus 4, is equal at every point as the function x minus 5 except at x minus 4. It's a line and it's got a hole in it. So anyway, the limit is x minus 9, and I always like to draw a little graph to remind myself what's actually going on there. I know it's a line, but that's not really important. What's important is that I know at -4, -9, I have a hole in the graph, and I learned in calculus that you just draw this little spider thing, meaning that I don't really care what's going on around that point or on the once I get past that point. I'm just looking what's happening there because I know there's a problem there. And in fact, if we know the domain, we know that there is no other problems on this graph. And like I said, it's actually a line that well, passes right here at -5, and I don't know where they say x-intercept 5, but anyway, that's it. Now I'll go ahead and I know this is running a little long, but I'll go ahead and do L'Hopital's rule. L'Hopital's rule says that, oh, what am I doing there? Didn't put an arrow. L'Hopital's rule says that if I have the form 0 over 0, which I did, then the limit as x approaches a number of this function is equal to, and I'm going to put this little LR right here, the limit, because I'm doing L'Hopital's rule, the limit as x goes to -4 of the derivative over the derivative. Well, the derivative of the top is 2x minus 1 over the derivative of the bottom is just 1. So now we have 2 times -4 plus 1 equals, am I running? No, I'm not running off the page. -8. Oh, sorry, it's not plus 1, it's -1, isn't it? Look at that. Yeah, of course you should get the same limit this process. -8, and since I'm running out of room, I'm just going to kind of talk through this. 2 times -4 is -8. -8 minus 1 is -9. So that's like the quick way to do it. And honestly, forgive me, but on the AP Calculus test, if something comes up like this on the multiple choice section, I generally will tell my students to not waste their time doing this, to just do L'Hopital's rule if they can't see it right away. And that's about it, and I'll do another one pretty quick on a separate video.